Hey, have you ever wondered what would happen if three people played a game where each of them rolled a different set of dice, but all could potentially get the same maximum score? Picture this. Player A rolls 8 six-sided dice, player B rolls 6 eight-sided dice, and player C rolls 4 12-sided dice. The target? All can hit a max score of 48, but who actually has the advantage? Let's break this down. At first glance, it seems fair. After all, each player's best possible roll is 48. But if you ever played games with dice, you know it's never that simple. Here's where probability, and a bit of sneaky statistics, kicks in. First, let's talk averages. Player A rolling 8d6 can expect an average score of 28, player B with 6d8 averages about 27, and player C rolling 4d12 lands closer to 26. Why? Because when you multiply the number of dice by the average result of each die, that's the expected total. So, even though anyone could roll 48, player A is likely to get a bit higher on average. But there's another twist variance. That's the fancy term for how much your total could swing from game to game. For 8d6, the total variance is around 23. For 6d8, it's about 31. And for 4d12, a whopping 48. Higher variance means more wild swings. Sometimes player C will roll brilliantly, but most of the time, their results will be all over the map. This all comes down to the central limit theorem and the law of large numbers. The more dice you roll, the more your total hovers around the average player. A's results are tightly clustered near 28. Consistent, reliable player B's results are a little more scattered. And player C, they're living on the edge with a score that could land just about anywhere between 8 and 48. So, in a series of games, or if you simulated this with a computer, player A would win most often, even though everyone's got the same maximum possible score. Player B would take second place, and player C, despite having a shot at the highest score, would actually come in last most of the time. Now, is this number theory? Not exactly. Number theory is all about primes and divisibility. Here, we're deep in the world of probability, statistics, and combinatorics, where math meets randomness. So next time you're picking your dice for a game, remember, more dice means more consistency and usually a better shot at winning. That's probability in action.